Hi everyone, welcome back to A+ Maths. My name's Heidi Postle. Today we're going to be looking at how to graph a function. Now there's a lot of work that goes into this topic because there's many different types of graphs. The ones that I'd like to have a look at today, firstly, we'll take a look at straight lines. Now you've done straight lines for a long time, so we don't need to spend too much time on those. Then parabolas. Then we'll have a better look at cubic functions and hyperbolas and exponential graphs. So we really would like to go through those one at a time. And of course, circles. So when we have a straight line, we should know that straight lines are always written in the form y equals mx plus b, just like that. You already know that the m is the gradient and the b is the y-intercept. Remember, the gradient is the slope of the graph, how steep it is. And the b is the y-intercept, and that's where the line cuts the y-axis. It's very important to remember that if the gradient m is positive, that's a plus, then the line will go in that direction. If the gradient of the line is negative, if it's got a minus in the front, the line should go in that direction. That's really important for us to be able to check our lines and to draw them really, really quickly. So let's take a look at an example. Let's say we have y equals x. That's the most basic one. So y equals x, you can either know what it looks like straight away, or we can draw a table of values. If we draw a table of values, we can pick the points for x. I've just picked -2, -1, 0, 1, 2, and 3. Then you find the y values. Then you can plot all the points on a graph and join up your straight line. If you have y equals 2x, the 2 in front of the x, of course you could draw a table of values, but the 2 in front of the x just makes the line steeper, like that. Of course, if we have the equation y equals a third of x, because a third is less than 1, that's going to make our graph flatter. Everything is compared to our original graph y equals 1x, because 1x will be exactly in the middle. So any number bigger than 1, the line will be steeper than the black line y equals x, and any number less than 1 will be flatter than your black line. So y equals 10x should be what? Should be a lot steeper. Good, that's right. And so we would draw it really close to the y-axis, like this. Great. Let's have a look at another one. Y equals x minus 1. Of course, we could draw a table of values, and we could get that. And then we could plot the points on an x and y axis. And this would be what the graph looks like after we plot our points and join the dots. Don't forget that really what we're doing is we have the line y equals x, which is there, and then we move it down 1 because the -1. We've got the normal graph y equals x minus 1. The -1 means down 1. Let's take a look at another one. Y equals 2x plus 3. So what does this actually mean? It means that you've got, of course you can always draw your table of values and plot the points, but let's have a look at the way that the graphs translate, move around the x and y axes, because that's going to be invaluable to us later. So we have the line y equals 2x. But what do we actually have? We have the line y equals 2x, which is just a straight line, and then the whole graph goes up 3. And that's what it looks like. If we have y equals 10x minus 2, of course, again, you could draw your table of values, plot the points, and then you would have your line, like this. And there's nothing wrong with doing it using a table of values. But when the graphs get more complicated, we want to know how to move them around. So, if we actually start from y equals 10x, y equals 10x is a straight line, quite steep, and then we're going to minus 2. That means that the whole graph goes down 2. Is everyone starting to get that? I hope so. Let's have a look at a negative one. Y equals minus x plus 2. This time we need to start with the line y equals minus x. Here I've drawn the table of values, and of course I can draw my graph from the table of values. And that's what I would have. But I know that I could get the same graph by graphing y equals minus x, which is a line going through 0, 0 in that direction, and then the whole graph would go up 2. Now let's have a look at some quadratic equations. Quadratic equations can come in many different forms. The most basic one, of course, is y equals x squared. But we can also have y equals x squared minus 3, or we can have brackets y equals x minus 1 all squared, or we can have y equals x plus 2 all squared minus 1, or we can even have y equals x squared plus 7x plus 10, or y equals minus x minus 2 all squared plus 3. There's a lot of different ways that quadratics can be presented to us, and that makes them a little bit more tricky. But let's have a look at the basic curves. So the basic curve for y equals plus x squared looks like this. And the basic curve for y equals minus x squared looks like this. And these are the two graphs that we're going to move around, just like we did with y equals mx plus b. So let's say we have y equals x squared plus 1. What do we know when we look at this equation? We know that it's got the basic graph y equals x squared, and then we have plus 1, which means that the whole graph needs to go up 1. Let's have a look at what that means on the picture. We're going to first draw our basic curve y equals x squared. We all know what that looks like, y equals x squared. Now we need that graph to go up 1. And then if you don't want to have the original y equals x squared, you can just rub it out and be left with y equals x squared plus 1. Let's say that we have, this time, y equals x squared minus 2. So let's split it up so that we know what it actually means. We have our basic curve, y equals x squared. We all know what that looks like. Then we know that we need to have that graph and we need to minus 2. And what does that mean? Down 2. We need to move the graph down 2. So we start with our basic graph of y equals x squared. Brilliant. Now we need to take that graph and move it down 2. Just like that. And of course, you can either rub out the other one, the y equals x squared, or you can just do it in very light pencil, or you can always highlight your answer. I like to just highlight my answer. Now let's try a negative x squared. Y equals minus x squared plus 1. So our basic curve here is y equals minus x squared. That's the upside down parabola. And then we have plus 1. And that means that our graph is going to go up 1. So let's take a look visually at what that does. We have our basic curve, always start at the basic curve. Y equals minus x squared. There it is. Now we need that graph to go up 1. And that's it. And you just rub it out or highlight your answer. What about this one? Y equals minus x squared minus 3. Again, we have our basic curve, y equals minus x squared. That's our upside down quadratic parabola. Then we have minus 3. What does that mean? It means the whole graph goes down 3. So we're going to draw first our basic curve y equals minus x squared. And then of course we're going to have the whole graph go down 3. And highlight your answer so that you know so that everybody knows which one is your answer. What about something that looks like this? Y equals x minus 1 all squared plus 2. Same thing. We have our basic curve, which is y equals x squared. Now there's something attached to the x. And when there's something attached to the x, that means it's going to move left or right. And in this case, because it's a minus 1, it's going to go to the right 1. So if it's a minus, it goes to the right 1. That's a little bit confusing, isn't it? And then after that, we have our plus 2, which means up 2. So we're going to start with our basic curve of y equals x squared, because it's a plus x squared. Y equals x squared. We then need to move this y equals x squared to the right 1. See, we've moved it to the right 1. That's now the blue graph. And then we're going to move that graph up 2. We've moved the black graph to the right 1 and then up 2. And then if it helps you, highlight the answer or rub out the other ones. I hope you're starting to get the hang of it, because once you get how to move them around, all the graphs are pretty much the same. Let's take a look at this one. y equals x plus 3 all squared minus 1. So we have again our basic curve, which is y equals x squared. We have something attached to the x, which means it's x plus 3. That means that the plus 3 tells us that it goes to the left 3 this time. The plus means to the left. And the minus 1 afterwards says the whole thing goes down 1. Let's do it. Remember, don't try to graph it all in one go. Do it bit by bit. We start by drawing y equals x squared. Then we want to move that graph to the left 3 places. Just like that. And now we're going to move that graph down 1. Just 1. And of course we can highlight our answer. Y equals minus x plus 2 all squared minus 4. Again, we start with our basic curve. Y equals minus x squared this time because there's a minus out the front. Be careful of that minus. So we have x plus 2 all squared. That means that our graph goes to the left 2. Good, if you're getting the hang of it. And then the minus 4 tells us the whole graph goes down 4. Always think about those things first. You've got your plus or your minus, your left and right, and your up and down. Now we try to graph it. Remember, don't graph it all in one go. We start by drawing our basic curve for a quadratic. Y equals minus x squared. That's the upside down parabola, like that. Then we have to move the graph to the left 2. So we move it left 2. And then the whole graph has to go down 4. And then you would highlight your answer. Are they so bad, or are you starting to see how it all fits together? I hope you're starting to see how it all fits together. If not, keep watching and you'll start to get the hang of it in a little bit. Here's another one. Y equals minus x minus 1 all squared plus 2. What does it mean? You've got your basic curve and it's a minus out the front. So that tells us it's an upside down parabola. Then we look at the bit inside the brackets because there's something attached to the x. And what is it this time? A minus 1, which means it's to the right 1. And the plus 2 at the end tells us that the whole graph needs to go up 2. Now we just need to draw it. Remember, slowly but surely. The first thing we need to draw is our basic curve for y equals minus x squared. Now we want to move it to the right 1. Good. And now up 2. And of course, you can then highlight your answer. Lots of people think that in maths that we learn all these different functions, but they're never ever going to use them in real life. Well, that may be so, but a lot of people do use these things. For example, parabolas are used in satellites as they are the best shape to reflect signals to the receiver. Most of you would have put a spoon into a cup and swirled the spoon around and made like a little mini tornado in your cup. When liquid is rotated, the forces of gravity actually result in the liquid forming a parabola-like shape. You can see here, in France, this solar furnace is used to capture solar energy to produce high temperatures. The mirrors are placed in the shape of a parabola to reflect the light onto a particular point, which is called the focal point, which you'll learn more about if you do more maths in your later years of school. The temperature can reach up to 3,500 degrees Celsius and can be used to generate electricity, melt steel, or make fuel or nanomaterials. It's actually quite interesting if you get into a career where you're using the maths to actually do something in real life. Let's take a look at ones that are slightly different, like the ones that are in brackets. Y equals x minus 2, x plus 1. Well, these ones are interesting because we don't necessarily need to follow the normal rules of moving the graph around. We know that this graph is going to cut the x-axis when y equals 0. And when y equals 0, we're going to have x minus 2 can equal 0 or x plus 1 can equal 0, which makes it x equals 2 and x equals minus 1. You should know that from quadratic equations. And if you've forgotten quadratic equations, go back to one of my other videos and take a look so that you understand what's going on. We can then draw our axes And we know that the graph has to go through x equals 2 and x equals -1, and then we just join the dots. Let's have a look at another one. Y equals minus x plus 1 bracket x minus 3. Same thing, except this time we have a minus out the front. And what does the minus tell us? That it's upside down. So we should know that if we solve this equal to 0, using our quadratic equations, we would get x equals -1 and x equals 3. Good, if you remember how to solve your quadratics, that's great. So we know it goes through -1 and +3. So you plot those points on your x-axis and then you draw your quadratic. Don't forget that it has to be upside down because it's a minus x squared because there's a minus out the front. If we have a number out the front, like this one, y equals -5 bracket x minus 2, x plus 2. Remember that the 5 out the front just tells us that it's all a little bit steeper or it's a little bit more squashed, steeper. Same as when you have a gradient out the front, makes everything steeper. So this time, remember we have to solve it to find where it crosses the x-axis, and that's going to be x equals 2 and x equals -2. Did you all get that? I hope so. So we know that this graph goes through on the x-axis, x equals 2 and -2. It's a -5 at the front, which makes it an upside down parabola, and then we just join the parabola through the points that we've got on the x-axis. How are you finding those? They're not too bad, are they? What if we have an equation like this? Y equals x squared minus 7x plus 10. We're going to factorize the graph first and make it into one of the ones that we just did. So if you factorize out x squared minus 7x plus 10, what do you get? Remember, if you've forgotten how to factorize, then you should go back to one of the other videos on how to factorize a quadratic so that you know what we're doing. We know that we're looking for something that multiplies to give 10 and adds to give -7. So we get x minus 5, x minus 2, which means that our graph has to go through x equals 5 and x equals 2 on the x-axis. So we plot those 2 points and then we know it's a plus x squared, so we get a happy graph through those 2 points. Let's have a look at another one. Y equals minus x squared plus x plus 2. Now that minus out the front is a little bit tricky. So the first thing I want to do is to factorize out the minus. And what do we get? Y equals minus, open brackets, x squared minus x minus 2, close brackets. And then we're going to factorize what's inside the brackets. So we're looking for something that multiplies to give -2 and adds to give -1. So we have y equals, don't forget the minus out the front, x plus 1, x minus 2. And from that we can tell that it goes through the x-axis at x equals -1 and x equals +2. I have to plot those points on my x-axis, -1 and +2, and remember that it's an upside down minus x squared. Let's try one that's a little bit different. What if we have y equals x squared minus 6x plus 1? So the first thing you're going to try to do is to factorize it. That's what we've done before. But nothing multiplies to give 1 and adds to give -6, because the only factors of 1 are 1 and 1. So what are we going to do? The easiest way to do this would be to complete the square. Now again, there's a whole video that I've done on completing the square. So if you're having trouble with the next line, it's not because you're having trouble with what I'm teaching now, the graphing, it's because you don't know how to complete the square. So you need to go back and learn how to complete the square. But if you remember how to complete the square, then you would know that I'm going to have my next line as being y equals bracket x minus 3, because that's half of 6, all squared, minus 8. Once we get that, we can then use all the rules that we know before about how to actually graph the parabola. Remember that what's inside the brackets moves it left or right. So we have -3 inside the brackets, and that tells me that the graph is going to move to the right 3. And then the -8 tells us bring the whole thing down 8. And so we graph it. You draw your basic curve y equals x squared. You then move the whole graph to the right 3, and then you move it down 8. That brings us to the end of the video today on straight lines and parabolas. I hope you enjoyed the lesson. See you next time. Don't forget to like and subscribe. Bye!